Like never mind. I just remember there's a lot of police because I remember not being in my total right mind and going into down the hatch thinking to myself, wow, are these policemen always here? I know. I was tripping.
Is that thing real?
I know. I was like, are they real? Are they always here?
You have to touch the vents now.
That's hard.
All right, 3 o'clock. Time to start class on the dot as usual. At least I try to. And right now we're in thermodynamics. Does anybody have any questions about anything before we start? Man, and the morning class is pretty sparse too.
Are people dropping out or something?
I have to check the class list. I haven't for a little bit.
I dropped out of the lab class. Changed to a different professor.
Who's your lab teacher?
Fisher.
Oh.
You have to. That's something you'd have to negotiate with them.
Negotiate with the professor.
Yeah, because
You're in different places.
Yeah, you'd have to negotiate that with them. If you want, we can talk after class and see if I can help with that. Question?
If you take this class this semester, isn't there like another core you have to take next semester, like chemistry 162?
Yeah, there is.
Okay.
You can't take 162 without 161 though.
Oh.
And I tried that when I got back from China. I wanted to take bio 162 or 172, but you can take 172 without 171. It's a year-long program.
The progression goes Gen Chem 1, Gen Chem 2, then Organic 1, Organic 2, most majors. What's your major?
Just like level arts transfer, I think.
To what ultimate degree?
Not sure yet. Just like transfer of credits.
Do you want to go biological or physical, or you still know?
Not sure. It's
Okay.
just like general credits for transferring.
Okay, because this is the STEM degree pathway.
Mm-hmm.
Do you need to take another lab for Chem 2?
Depends on what your major is.
We don't have to. We went over it.
Yeah.
So,
Showed you the list.
certain engineering, it depends. Certain engineering do not require. I don't think mechanical requires.
I require all the sciences. I'm going to Gila's molecular program.
Yeah, well, it's the secrets about it, people. I've never taken a biology class, at least in college. Last biology class I had was freshman year of high school.
Huh.
But yeah, if you want to take 162, you should take 161. And then organic. What's that?
This is 161.
Yes.
Yeah.
Did I say 160? Did I say that again?
No, you said it right.
Yeah.
Okay. All right. Yeah.
I'm very tired.
So am I, actually. So.
I feel great.
Okay. And after this class, we're gonna have a problem session in the Astro Lab.
Yeah.
Okay. So and that's going to be every Wednesday from now on.
Really?
Yes.
Yeah.
Oh, that's exciting.
So I'll lecture capture it and post it so if you guys can't make it.
Science.
Okay, so last class we talked a little bit more about enthalpy, delta H, and now we're going to apply enthalpy to problems. So we have a liquid propane gas tank with a home barbecue that contains 13.2 kilograms of propane. Calculate the heat in kilojoules associated with the complete combustion of all the propane in the tank. So if you see here, we have propane plus 5 oxygens makes 3 carbon dioxide and 4 waters, and the heat of reaction here is minus 2044. That means that as this chemical reaction is written, it produces it evolves exothermic 2044 kilojoules. And sometimes the units on this is mole reaction. That's mole of this entire thing as written. I mean, it's 1 mole of propane to the mole reaction, of course, but say if you're looking at oxygen, for every mole of oxygen, it's going to be 1/5 of that, because there's a 5 here, for instance. So stoichiometry works with energy as well. So 7B, correct.
7B.
Okay, so how we do this one, so 13.2 kilograms propane. And then this is just straight old dimensional analysis. And then let's see here. So we've gone to grams. Now we need to go to moles. C3H8, and 3 times 12 for carbon plus 8. That's 44 grams C3H8. And then we have 2044 kilojoules per mole C3H8 by the chemical equation. And if you put that out, you get, I guess I should put the negative sign there because it's exothermic, minus 6.12 times 10 to the 5th kilojoules.
Wait a minute.
Too fast?
That's a negative
Yeah.
in front of the, and is that 2.044 or is it just 2044?
2044. Because right there.
Because that's what it says.
There's no point there. Maybe this will help. 20 negative. Is there? There's an I usually use the dot as a multiplication sign. That's
No,
the
sorry, I
same.
thought you said point. I thought you said
Oh.
2.014 kilojoules.
20. Okay. I
I'm
don't
just
know.
hearing myself.
Maybe I did say it. I'm getting kind of tired.
I think you might have.
But I wrote exactly what I said down. Okay, so recap for this one. This time, though, we're using dimensional analysis, but we're also including energy in with the stoichiometry. And as this equation is written, as this entirely reacts by these ratios, 2044 kilojoules of heat are evolved, are exothermic, going out, negative. So remember, negative means leaving the system. In this case, the system is a chemical reaction. And there we go. Questions with this one? How it works? No? Okay.
This is how you heat up a gas barbecue?
Yeah.
A barbecue? Oh,
Mhm.
cool.
I had I grilled some steak for myself last night for dinner.
Yum.
Okay, I think you have a lab like this. I don't quite recall, but I think you have one where you do energetics in the with a coffee cup calorimeter. So this is just kind of like the one we did before last class, except in this one, in a way, it's simpler because we're not using the whole heat capacity. The same thing where you get the energy per mole. So magnesium metal reacts with hydrochloric acid by this way. Magnesium plus 2 hydrochloric acid makes magnesium chloride and hydrogen gas. An experiment to determine enthalpy for this reaction, 0.158 grams of magnesium is combined with enough HCl to make 100 milliliters of solution. The HCl is sufficiently concentrated so that magnesium completely reacts. Temperature of the solution rises from 25.6 to 32.8 degrees Celsius as a result of the reaction. Find the heat of reaction as written. So for me, I've done this too many times where I've missed a negative sign and I've gotten the wrong answer. So I always take the intuitive approach to this. Meaning I look at the reaction. The reaction is causing the temperature of the solution to rise. So I know that the reaction is exothermic. So right away at the end, I know that I'm going to make sure that my reaction has a negative sign there. If you want to do the left-brained approach, so left brain meaning like very logical, stepwise, the way you do it is say the minus the heat of the reaction is equal to the heat of the solution. So meaning the heat flow of one is opposite the other. It doesn't really matter which way you do it. So then we do the heat flow of the solution. This is going to be mass, specific heat capacity, change in temperature. So the mass is you have 100 milliliters and then times 1 gram per milliliter. That's the mass. Specific heat capacity, 4.18 joules per gram degrees Celsius. That's given. And the change in temperature was always final minus the initial. 32.8 minus 25.6 degrees Celsius. And if you do this, you get 3,000 joules as the answer for that. Okay, and that's positive. And doing the final minus the initial, you get the positive result. That is heat flow positive into the solution. So heat flow into the solution is positive, which is not surprising. We find out then that the heat of reaction for this small one here is minus 3,000 joules. Now we have minus 3,000 joules per 0.158 grams of magnesium. Oh, and I should say the other thing with this is a limiting reagent problem. I didn't explain that. These hydrochloric acid is sufficiently concentrated. That means that there is excess. So there is excess HCl, so magnesium is our limiting reagent. But I'll keep on going then. Magnesium, it's 24.3. Let me see. What is magnesium? 24.3. Yeah, 24.31. 24.31 grams of magnesium per mole of magnesium. And this equals, that is going to be minus 4.6 times 10 to the 5th joules, or 460 kilojoules per mole. So, like so. And again, I think you're going to have a lab like this, so it helps you to see the calculations the way they work out. Of course, in the 5 minutes we spend in here in lecture, you're going to probably be confused again in the lab. Which way do you prefer? Do you prefer the intuitive or the left brain, or should I do both? I guess I'll just do both. Intuitive is that since the temperature of the solution is going up, the reaction is exothermic. So just make sure that your negative number down there and all is good. Left brain approach is the heat flow of the reaction is opposite the heat flow of the solution. Apply the equation. Heat flow is mass, specific heat capacity, change in temperature. Change in temperature is final minus initial. Putting this in, we get a positive heat flow into the solution, which means we have a negative heat flow, exothermic with the chemical reaction. And then by ratio, 3,000 joules from 0.158 grams of magnesium, converting units to moles, gives us minus 460 kilojoules per mole magnesium reacting with this chemical reaction. And since it's 1 mole magnesium per mole reaction, we keep the stoichiometric ratio there at 1. Question?
The heat of the solution, what is that mass times?
It has specific heat capacity. CS, specific heat.
Okay, and then is that a D or a triangle?
That's a triangle.
It's
It's
a
a
triangle.
delta. It's a triangle. It's a
The change in temperature, yeah?
yeah. That's a delta. That's a
Yeah,
CS.
for change. So kind of
Capital
like
delta.
Yeah, kind of like a capital D. And then that's
It is a capital D, but in Greek.
The 4.18, that's over grams Celsius, yeah, okay.
Joules per gram Celsius.
Okay.
And
And then you get the negative 3,000 from the opposite of the heat
yes.
solution. Yes. Okay.
Yes, correct.
And then,
And the heat capacity is given right there. Other questions? Oh yeah, that's right. This one was ugly.
That's not nice.
Well, the picture is ugly. I'm glad you have a filter.
It's a new thing.
Occasional.
So here are some rules with delta H. If the chemical equation is multiplied by some factor, delta H is multiplied by the same factor, delta H reaction. So, but this makes sense, right? So if I can go 30 miles in a gallon of gas, if I have 2 gallons of gas, I can go 60 miles. If I have a half a gallon of gas, I can go 15 miles, right? That makes sense. So the other one is, if a chemical equation is reversed, delta H changes sign. Also makes sense. The amount of energy that it takes plants to undergo photosynthesis to make glucose is the same amount of energy that I get when I eat glucose and then digest it, right? So so it depends on the direction. So plants make glucose from carbon dioxide and water and produce glucose and oxygen. And for me, I breathe in oxygen and burn glucose and make carbon dioxide and water. And then that energy that the plants use to make it, I then use it for my body. And the last one here is, if a chemical equation can be expressed by a sum of series steps, the delta H reaction for the overall equation is the sum of the heats of reaction for each step. This is also known as Hess's law. And so kind of think of it like altitude, as I was trying to explain to an earlier class. So let's say I want to figure out what the altitude is at Krispy Kreme. So I can take my altimeter and I can just go there down Kahamanu Avenue. But if I wanted to, instead of going straight there, I could go up to Wailuku, drive around, come back around by the airport, and then get to Krispy Kreme. Right? So it doesn't really matter which path I take, because enthalpy H is path independent. It's path independent, so I can take whatever way I want, and I will always get the correct answer, because, like I said, it's path independent.
So it's a vector.
It is no, it's not. It does not have. It has a. I guess it has a magnitude and direction, so that would be heat flow.
So it'd be trying to relate this to physics.
Yeah, I know what you're thinking, or at least I see what you're saying. I mean, it has a direction. I mean, I see that you would say that's a vector, but you don't really do any vector math with it, though, right? It's really only one way. It's either positive or negative. You don't have it in like an angle where you have components, right? So it would be like velocity.
Yeah, that makes sense.
So okay, let's do this for Hess's law. And I actually like these. I always have fun doing these. And it's not that I'm sick and twisted. I just like solving puzzles. So if this is a puzzle, if you think of this like crazy chemistry and math, you're going to have a bad time and you're going to hate it. But if you think of it like a puzzle that needs to be solved, then these actually become kind of fun. They used to have chemistry apps that had these games, but they keep on updating the systems in Android and Apple, and they don't work anymore, unfortunately. I had some fun games I used to play. But okay, well, Hess's law here. So we want to figure out what the delta H, so the heat of reaction for 3 carbons plus 4 hydrogens makes propane. This is also known as the heat of formation of propane, because you're forming something from elements. And this would be a hard experiment to do, but what you can do is go to the library or the internet and look up some reactions, and it's nice to have them all be a similar reaction, because then it's easy to cancel terms. But so you can look these up, but it's much easier and more fun to burn things, right? So I can burn propane, I can burn carbon, I can burn oxygen, and from these I can go and I can backtrack the heat of formation of propane. And when I do this, what I always do, first thing I do is I take the energies and I assign them numbers. I just in line H1, H2, H3. Then the next thing I do is I make sure that the reactants and products are all on the proper side. So what I mean by that is, for this reaction, propane C3H8 is a product. And here, in the first equation, it's a reactant. So what do? I have to switch this. So I'll make my pen bigger. So 3CO2 plus 4 waters yields C3H8 plus 5 O2s. And This is minus H1 because I flipped it. You see, I wrote the first equation backwards. I put the products on the left and the reactants on the right. And so when you do that, that's one of the rules, delta H changes sign. Next equation, I don't have to do anything. Carbon plus oxygen makes CO2. That's H2. Next equation, I don't have to do anything either. 2H2 plus O2 makes H2O. And this is H3. So there's two ways to solve this from here on out. I'll go through both ways. So the first way you can solve this is to look at the reactants. So I apologize if anyone's colorblind, but I'm highlighting this in yellow. And notice that we have the carbons here.
Yeah.
The carbons here, there's 3 carbons in the equation that we want, and there's 1 carbon in the equation we have there. So what do? We multiply the equation by 3 to get 3 carbons, 3 oxygens, 3 CO2s, and 3 hydrogens. Or I'm sorry, H2s. H2 is hydrogen. I should say enthalpy 2. So does everyone see why I multiplied that one by 3? It's because you have a 3 here, and you have a 1, and you had a 1 here. So you need to multiply by 3 to get that 3. All right, go
We're
ahead.
trying to balance according.
We're trying to generate this equation.
Okay.
And then likewise, since there's a 4 here and a 2 here, we have to multiply this one by 2 to get 4, 2, oh, this should be 2 waters. That's why I put 4 there. I forgot to put the 2 there. 2H2O, and this is 2, 3. So is that good so far? Now we're going to add them together. So I'm adding these 3 equations, and let me show you. The other class had a hard time with what I was doing, but if you notice that we have 3 CO2s on the left and 3 CO2s on the right, they can cancel. 4 waters can cancel, and then 3 plus 2 is 5 oxygens. This can cancel with this by the nature of both sides of the equation. Meaning, if I have something like this, if I have carbon plus O2 goes to, I don't know, this would be a weird, if we have an equation like this, the oxygens can cancel. So, but if you do this, you get 3C plus 4 H2 makes C3H8. And the sum is minus H1 plus 3H2 plus 2H3. So, but let me take a step back though for this. When I added these together, I know I made it all kind of. Didn't mean to erase 3 there. Before I put all these lines and everything. So let me show you when you add this together. So I'm just going to add these together the long way. We have 3 CO2 plus 4 H2O plus 3 carbon plus 3 oxygen plus 4 hydrogen plus 2 oxygen yields on the other side of the equation C3H8 plus 5 oxygen plus 3 CO2 plus 4 H2O. You see what I did? I added this, and this right there. And this right here. And the 3 oxygens plus 2 oxygens, this also equals 5 oxygens. So that's how these can cancel here. And then you have the 4 waters, and the 3 CO2s, the 3 CO2s are on the both sides of the equations, they can cross cancel that way. So your face is looking
No, I'm tired.
Okay, I'm trying to read your body language. Is this making sense?
So you just,
And why are we doing
The whole point of this,
it's to measure that?
we're getting the energy for this. Find the delta H for the reaction here. And so say I want to make propane. That means I'm going to take carbon, solid carbon, stick it in with hydrogen and let it react. That's a very hard reaction to do. But an easy reaction to do is to burn stuff. It's a lot more fun, right? I can burn propane, I can burn carbon, I can burn hydrogen. And that's really easy to measure, really easy to measure. But since the enthalpy, the energy, is path independent, kind of like altitude here on this island, it doesn't matter how I get there. If this is a real hard trek to do, if I take a shortcut, so if I want to figure out what the altitude is at the, I don't know, at somewhere remote, I can just take a helicopter and then an altimeter. It's all good.
So why are we adding these equations?
These ones here?
Yeah.
Well, for this one, it's given, but these information, it's easier to, this way you can
Like,
figure out that
Like, where do
value.
they come from?
like why are we adding them to get that reaction? What's the relationship between the reaction we're given and those 3 reactions below?
That question.
So, well, the relationship is Hess's law. If you can express, instead of, you can do stepwise. You can go a weird way that doesn't make any sense, but since energy is not, the enthalpy is path independent, it'll get you to your answer.
So these 3 equations,
so are we on standard enthalpy change?
Not yet. That's next class.
Oh, okay.
so
This,
because to me it looks like just 3 separate chemical reactions.
yeah, it is, but energy-wise, it works out.
So the energies from these 3 separate equations is equal to the energy of that
Yeah, it
given
is.
equation,
It is.
and that is because of Hess's law.
Look right
Okay.
here. So it's change in H3 equals change in H1 plus change in H2? Is that where we're at?
We're at Hess's law. I don't know what you're talking about. I'm sorry.
Sorry, I'm looking at the plot.
Okay, so are you? Have you done math where you have like contours and you have functions that are contours of things?
Like systems of equations.
No, 3D graphing.
Nope.
Okay. So in chemistry, we use something we call a potential energy surface. So potential energy surface meaning that if you, where you're at in terms of the orientation of your atoms, you have different energies. So energy being a potential, high potential energy means that there's a lot of stored energy. Low potential energy means that there's not very much energy. It's very stable. So high potential energy things are typically reduced states and or explosive things. Low potential energy are things that are oxidized and are not very useful. So energy-wise. So what this is there's different points along the potential energy surface, and there is one way you can go, which is a direct way, but it may be very difficult. But if you have information on the other way, you can go around a roundabout way to get there. So what we're doing is we're going a roundabout way along the potential energy surface to get to the answer we need by not doing any experiments. So there's a saying that goes, if you spend a day in the library, you can save yourself a month in the laboratory. So rather than carrying out this experiment, which would be a royal pain, you can either do these experiments, which are really easy, or you can look these up and then just calculate out the energetics by using the relationships of delta H and the potential energy surface. That's the potential energy surface is that's like what you would explain in graduate school, but I know we're in freshman chemistry.
Yeah, I guess I'm just having
A hard time
A hard time.
clicking it.
Understanding why we chose these three equations.
So first of all, this is academia, and we're preparing you. So you're given these equations.
So it's just a theoretical kind of.
No, you can
So
really
is
do
it-
this.
You're
This is-
manipulating the
Those
reaction,
three-
yeah?
Those three are easier to calculate, and then once you multiply them and cancel out, you get the same
Yeah,
reactant
you get
or the
the
same
original
product
equation.
as the original.
You get the original, not even the product, the original equation.
Okay, so you chose these three just because once you do all the canceling, you get back to your original.
When you pick them, if this was not a school problem in a textbook that had given information, if you were doing this on your own, you would pick equations such that any intermediates would cancel out. So you would have to do the same thing. So this is easy as oxidation. You could do reduction instead, or something that, and you would use the same reactant, so that way they would cross cancel.
Okay.
That
And the
makes
reactant is the O2 here.
Yes.
Okay.
And this is all to find an easier way of how much energy that reaction produces.
So we're trying to find delta H for this original carbon plus hydrogen. right?
3 carbon plus 4 hydrogen makes C3H8 propane.
Okay.
So you're trying to do that, and you're given, and you have these three equations, and if you take the opposite of the first one, and then 3 of the second and 2 of the third, and you add them together, the oxygens and carbon dioxide and waters go away, and you get the original equation.
And they go away because they're on opposite sides of the equation.
Yes.
They cancel out.
Yes. See, this is written out the long way. This is written out the long way, and we have 3 CO2s, 3 CO2s. We have 4 waters, and we have 3 plus 2 or 5 oxygens and 5 oxygens.
But isn't the first one negative?
Yes, the first one is negative.
I don't see it negative on the bottom.
So that's
So what do you
so
mean?
that's 4.
On the bottom left, no?
Why it's not negative 3 carbons?
Yeah.
Well, because when you flip the equation, then you flip the energy. So
It's only the energy that's getting reversed, not the signs of the
Yeah.
All
not
the
coefficients
valve,
of
okay.
yeah, we have the aha moments.
I mean, I see how it works mathematically.
Yeah.
We just had to talk this
I'm
through.
just not sure.
And this is all mathematical.
Yeah. Okay.
It's mathematically, you have a potential energy surface that's a mother function.
So it's not like if you do those 3 experiments, you'll get C3H8.
No. But
You're just using these
you'll
three-
get the information to make the calculation.
You're just using these 3 to calculate the energy
Yes,
from the
Yes.
C3H8
correct,
reaction.
correct.
Okay. And later on, we will be given these equations to work out, or we will have to. find
You will be given
ourselves?
them. You'll be
Okay.
given them.
But if you're like doing this, as a job, would you
Doing
have to look
grad
for?
school.
Yeah,
You'd have to figure out what equations to use to.
yeah. You wouldn't. You could do this on undergrad. You could do this after this class.
Yeah, I mean, just like
Oh, I want to.
general, in a more
Yeah.
practical sense.
Yeah, in a practical sense, you would pick something that you use the same reactant, so it's easiest to get rid of the intermediates.
Okay.
Yeah.
Okay.
Because let's say if you did one with oxygen and one with chlorine, you're gonna get a different product.
Right. Yeah.
So,
Okay.
And you have a question?
yeah, do you just add up the changes in age to get,
Yes.
So then
The
it's just
energy.
you replace the ages with their actual values, and then you do multiply it by the 3 and
Yes.
Yeah.
And that is the next step.
Okay.
Excellent suggestion. So that means the delta H reaction is going to be minus H1. So it's right here. It's minus a minus 2043 plus 3 times minus 393.5 plus 2 times minus 483.6. Oop.
Whoa.
Sorry. There we go.
Yeah, thank you.
And
That's-
then what does that equal? So I'm not going to do the calculation. Minus 105
It's 105, yeah, minus 105.
kilojoules. And there is the answer.
So that's, wait,
Okay. So let me explain another way that's equivalent. So what do we have? We have, so 3CO2 plus 4H2O yields C3H8 plus 5 oxygens. Carbon plus O2 makes CO2. And 2H2 plus 2H2. Okay. So, and what we need that's what we need. Okay, so the other way you can go about this is you can look at getting rid of the intermediates. So meaning here for water, we have 2 waters there. So this is minus H.
So you basically want to end up with C and H and C3H8.
Yes. 3C, 4H2, C3H8.
Right.
So the other way we can go about doing this is getting rid of the intermediates. So for water there, so I need to have 4 waters. I need to have the same number on both sides, and 4 is an easy number. So I need to multiply this one by 2 to make this 4 waters. And for CO2, I need to multiply this one by 3 to make it 3 CO2s. So that's why I have a 3 and 2. So, and it's the same thing. You get the same answer as going by the reactants that I did the previous one. But you see that another way you can do this is not look at the reactants directly, but look at getting rid of the intermediates. Intermediates being carbon dioxide and water, and oxygen in this case. So that's another way. Okay, so recap for this one. We are doing Hess's law. We want to see what the energy is for this chemical reaction. 3 carbon plus 4 hydrogen makes propane. And instead, we go to the library, and you remember this awesome chemistry teacher who told you to look things up that had the same reactants. And you did, and you found these 3 equations. And then you took the first one and you flipped it, because C3H8 is a reactant in the first one, it needs to be a product, so you flip it and put a minus in front of the enthalpy, the heat. Then the second one, because there's 3 carbons or 3 CO2s, you multiply that one by 3, and for the next one, there's 4 hydrogens or 4 waters, you multiply the bottom one by 2, and so then you have 2 H3s, and you add the equation together, and you get the original one, and the energies are opposite of the first enthalpy plus 3 times the second plus 2 times the third. Put those numbers in, you get negative 105 kilojoules. And then you eat chocolate. Okay. Questions with that? All right, your turn. This is what we need.
Do this.
This is what you need.
see what's happening.
And this is what you're given.
Okay, I'm sorry. What are we doing? Everything else?
And
Still have the offer for the chocolate?
Yeah,
Maybe I'm thinking M&Ms.
and this
Love
is the
M&Ms.
equation we wanna write.
Yeah, that's the one you want. Starting from those.
We don't have to flip
Do we
them
have to?
around, right?
Ooh,
We don't have to
we're
flip
so
that line
connected.
The top one you do have to flip because the NO is a product, and you have to have it on the other side.
The very first,
Oh,
the negative 69 point. Oh wait.
Where are you getting that?
Well, yours is zoomed in, mine is zoomed out, so I'm
Oh.
talking about the one
No,
that's
those are
directly
the,
across. That's-
Answers for after.
Yeah, I was talking about the one that's like in the same line as the negative 6, which would be that 2NO plus O2.
Michael, this
You
one
weren't
you do have to
here.
flip
We have
because
chocolate.
this is a reactant
Uh-huh.
and that's a product, so they need to be on the same side.
So it's 2NO plus
So you have to flip
2NO2.
So,
What?
Nothing.
so it would be negative 3, wait, where?
It'd be
Oh, the
positive
second
1
one, the
and 2.
second one. Okay, so it would be negative 2 NO2 plus O2 minus 2 N2. If
You don't put a
flip it-
you don't put a negative sign on the coefficients.
You put the
You
negative.
put the negative on the energy.
Yeah.
Okay, so you can
that's
just
gonna turn
switch
into a
them.
positive.
Yeah.
Okay.
So is it 2NO plus 2NO2?
It's 2NO arrow. If you flip it, it's 2NO2 yields 2NO plus O2.
Okay, you gotta move both of them if you're gonna switch them around like that. Okay,
Okay.
see how you play it?
And you flip the energy.
Flip that.
Are you gonna be going? Questions?
And that one is.
Not yet.
correct.
Worried?
No, wait, you're in the morning class, right?
Oh, okay.
She's always in this class.
I was playing.
It's right across the me.
There's someone that comes sometimes. I forget.
So the reason.
That out.
That's right. So far, now you got to multiply by terms. You know, multiply term. You have to find the equation N2O plus NO2 makes 3NO. You want the energy.
Oh.
You have to generate that equation using those three, the bottom or the middle three, the three in black.
I don't know what to do with the bottom one.
Do nothing.
That doesn't have an NO.
Start off with. It's over.
Okay.
So when we add this up,
Do you have to flip the bottom one? Or no?
no, because N2O is a reactant. You want reactants on the left, products on the right.
Oh, okay.
So when you do this though, notice that you have two O2s on that side and one on this side. And you have one N2 and two N2s over there. So what do you have to do?
Multiply that one by 2.
Yeah.
Yeah. And then when you add them together, the oxygens cancel, the nitrogens cancel, and you get 2N2O plus 2NO2 yields 6NO minus H1 plus 2H2.
Why did you times the second one by 2?
Yeah.
Isn't it?
You need four. You need 4
Why do you
nitrogens
need
and 2
4?
oxygens for.
So-
Oh no, the
balance.
top one has
So-
4
Because this has two oxygens here, and then you had one oxygen here. You need to have the same number of oxygens on this side as that side to get rid of them, because oxygen is not in this equation. So you need to get rid of the oxygen. So it's getting rid of the intermediates. So you multiply this one by 2, and you have 2 nitrogens here, so you need to get rid of 2 nitrogens that way. Does that make sense? It doesn't look like it's clicking for you.
So 4 oxygens on the right side. You put a 2 in front of the O2 to make that 4 oxygens on the left side. So
Well, it's 2. Yeah. Well, four oxygen. You mean 4 oxygen atoms, or because there's 2 O2s.
And then you just add a 2 in front of the O2 just to make it 4.
Yeah, but we have to put a 2 over this entire equation.
Over the entire thing.
Yeah. You can't just do it here. You have to do it over the entire
So
equation.
you're not comparing it to the top one. You're just trying to balance each side.
I'm trying to generate this equation, and this equation doesn't have any oxygens or nitrogen. It doesn't have any O2s or N2s in it. So I need to get rid of the O2s and the N2s in this.
So
Oh, okay.
the O2s and the product sides cancel each other out.
These N2s cancel out these N2s because they're on opposite sides of the equation. This 2 O2s cancel out 1, 2 O2s.
Oh, 4, because there's 4 O2s now.
Well, there's 2 on this side, and then there's 2 on this side. So there's
4 total though on the left side, and then that's why.
there's only 2 on the left side.
Okay. Okay.
Oh,
Okay, let's instead of arrows, would it help you to see equal signs?
that'd be so funny if you put equal sign and it clicked.
Okay, let me do this.
There's the 2 O2s is 4.
Practically the arrow doesn't really matter.
There's only one O2.
Just
So
And if you add these, if you add this, so instead of an arrow, you have an equal
Before you
sign.
times it by 2, there's only 1. And there's
2 NO2
times one more.
plus 2
So you're times
N2
it by 2
plus 2 O2 plus 2
This one was
and 2O equals 2 NO plus O2 plus 4 NO plus 2 N2 plus O2. Should I maybe I should make my script smaller.
That 2O2 cancels out the O2 and the O2, yeah.
Yeah, so
Okay.
you
Those are
you have
All I
a
needed.
2O2 here, and you have an O2 here, and an O2 here.
And so because you multiply the second one by 2 for the O2, you
It
got
it
do 2
distributes
across the whole
entire
thing.
Yes.
So then you get the 2 and the 2.
Alright.
Okay.
You know what you could do?
A2.
You could replace each of the chemicals with like a variable ABC.
But I'd like that
Okay.
one better.
All right, as you wish.
That's how I was thinking of it at least.
Okay.
And then just solve it like a system of equations kind of thing, where you have a set outcome that you're trying to get.
2 and 2.
All right. I'll call this A. I'll call this B. I'll call this C. I'll call nitrogen D and oxygen A, B, C, D, and I'll call oxygen E. Is that good?
Yeah.
Okay.
They-
So if we're gonna do that, it's gonna be
Oh, it's 4 and wait.
6.
so this will be 2C plus E yields B to B. Yes. Okay. Then N2 is D plus E to C. N2O 2A yields 2D plus E. And we want,
Oh, okay, thank you.
and you want A plus B makes 3C.
I have a question.
Yes.
do you combine, so the only thing left on the left side after all your crossing out and everything is 2NO2 plus 2N2O.
Yeah.
Yeah, and then the right side, the product side, is 2NO plus 4NO. Do you just add that to make 6NO?
Yes.
Oh, and then
Alright,
if you
and
divide
then
by
you-
2,
and
you
then
get
you
the
add
original
the-
equation.
And then you change the negative 113.1 to a positive 113.1 and then add it to 2 times 182.6 plus negative 163.2 to get your kilojoules.
Correct.
Done.
Okay, so this system of equations, and we want, so as suggested, all symbolic. We need A, B, and C and when you add these together, I'll get rid of I'll get this equals. And so we have 1D here and 2Ds here, so we can multiply this by 2. Like that. This way the 2Ds will cancel, and wait, I'm doing something wrong.
I think you didn't flip one of them?
Oh, I didn't.
You flipped the first one, right? Yeah, I think you need to flip the first one.
Yeah, okay.
I didn't get any of the answers.
And then, did you divide it by 2? Then 2 E's, and then the E's there. And we're left with 2B, or 2A plus 2B makes 6C minus H1 plus 2H2 plus H3. And so we gotta divide by 2 to get A plus 2.
Then do we divide we don't divide the H's by 2 though, right?
Yes, you do.
Oh, you do.
Oh,
So do you,
wait.
What are you dividing by
Would you
2?
divide the final answer by 2?
yeah, I
Oh,
think so.
Where are you getting
Okay,
this
okay.
division by 2?
because
Because you want.
this is what you get left over,
Mhm.
but you want this original
You
equation?
can factor.
I know that I'm talking.
Oh,
Are you guys following? Any
yeah.
questions? I know that they're talking a lot. Are you guys?
You can factor out the 2.
Huh.
You can factor out the 2.
I'm just, okay.
2, 2, 6. You can
So
factor out
So
the 2.
then I'm going to,
Okay. I forgot that we needed to be the original equation. So do you divide your 315 kilojoules in half too? Yeah.
You divide the whole whatever the sum is by 2.
okay, now I gotta answer. I like how one answer was before you divided by 2 and one answer is after, just a trick that's very.
But it's not
Very
quite right.
evil.
That's the thing is it's not quite right. We were like, oh, it's 314, but we got 315. It must be close enough, so it must be right.
But even
then we missed
157
that.
if you round it is 58. It's very.
I just calculated it first and I multiplied by 2. Okay.
It's very mean of you.
Thank you. So recap with this one. I don't know if you like the symbolic one better or the using the elements in their native form. So here we need N2O plus NO2 makes 3NO. And we have these 3 equations. We flip the first one to put the NO on the, the NO2 on the reactant side and the NO on the product side. And then second one, we originally leave it as is because it has the product on the right side, and then you have the last one has the reactant on the left side. So you leave it, and then looking at eliminating the intermediates, you multiply the middle equation by 2. You add it together to get twice the equation. So you divide it by 2. That means you also divide the heats, the enthalpies divided by 2, and then you get the proper answer, the 157. That makes sense.
It clicked. I like when we do classwork like this.
You know, what really helps problem solving. I think really helps students when it comes to homework.
Okay. Oh, doing the homework in the.
Yes, I like this.
Yeah.
Instead of like going through the book and having us read everything. Not saying that I don't do that.
Well, you need both. I mean, you need the context to why you're doing this stuff.
It took a while, but that's just clicked for me.
Yeah.
I like this one.
No, it's fine. I mean, and the morning class doesn't really say anything. They just kind of stare at me. So it's fine. I mean, I'm used to. Sometimes when you teach chemistry, it's like talking to a graveyard. But we have 20 minutes, and I have more problems for you.
Okay, let's do this. Where? Okay. Hesse's law. Hesse?
Hesse's. Okay.
And how do you read that? The change in heat reaction?
The delta H, the enthalpy of reaction, the heat of reaction, these all mean the same thing. You can say enthalpy of reaction, or my thermo professor was Indian, so it's enthalpy. The enthalpy reaction is so.
That's not entropy.
Yep. And entropy is entropy. So enthalpy, entropy, and I had a hard time following this lecture.
And you also asked entropy reaction.
Are you talking about Booty right now?
No,
No,
my
his
professor-
teacher.
my teacher.
That's racist.
No, it's
No,
his
all
name
Indian
is
guys are the
Sarwan
same.
Sandhu. He's a friend of
Also
mine.
I know.
Yes. India has like 1.3 billion people.
And they're always the tech scammer.
That's stereotypical. Shame on you.
But no, I've had
And Americans are all fat, and we like McDonald's, right? So
yeah.
and we drink out of red Solo cups and wear overalls. That's what, and have guns and wear cowboy hats. That's what the rest of the world thinks. Okay. So it's very similar to the problem we had. So how do you do this one? Do you want to work on it, or do you want me to work on it?
Wait, let's give us a chance. I like that.
All right, give you a chance.
You know, you need help? Oh,
That top one's H1, it just is too long, you have to fit nicely.
Yeah.
Okay. I don't know why that.
Yeah.
So I want the C class or the phone.
I guys don't have any questions. You guys have any questions so far?
None, we're good. Too quick. I'm sorry, same one.
Please.
We're doing the same.
Where's this problem from?
Something happening?
Um,
Fisher's class?
Oh, no.
Something a lot more in the future. I mean, some people like them, some people don't. I mean, it's just, and some people like Jeff, and some people prefer Fisher, some people prefer Tibbets. Some people hate me. No, I mean,
There's nothing bad that happened. It's just like
Not a match.
no, not a match. But I mean like grading.
Yo, that is how I feel about my math teacher. I'm like, you're messing with my grade, and my GPA is really important to me.
Yeah, I have a 70 right now, and I did like all my labs with a bunch of like in detail writing as much as I probably could. But I forget to like show like maybe like something I typed into my calculator, and it was just like one part of like the answer to the problem, but I already got the right minimal things that weren't really needed.
And are
Even
you
though I
sure it's gonna be better with Jeff? Okay, but I don't know, so what we can do is say, that you have a work issue, that you need to change your times.
You could come to our class with Tibet Tuesdays.
Something. Or do you wanna talk about it later?
I'll have to talk about it later because I'm busy after this class.
Yeah, but, it'd be better if we said it. I don't know if we'll be able to switch.
What time is that lab?
4:30, like sometimes 6:30 when
What
it's
time?
long.
Just starts at 4:30
I mean,
and
what
goes to
day?
whenever.
Tuesday.
We have a Monday morning with Tibet at 9.
That's different, that's not a lab.
Yeah, my math teacher has actually failed me 2 tests now. And I went to like the math lab and I was like, isn't this right? And they're like, some of it's right. And I was like, but like at least 5 to 7 points of it could have been earned back. I don't like teachers, especially teachers that teach algorithms, where as long as you get the right answer, why does it really matter? But yeah, she taught me a lot of
But
points
they just
for
want to see
like,
like the work.
yeah, she wanted me to like have written explanations. I was like, chick, this is math
Are you in
class.
that
This is not
class?
a
Here's the time. So for Dr. Tibbet, Monday 9 to 11:15, Tuesday 4:30. Yeah, so you got Tuesday 4:30 and Monday 9.
Okay.
Oh, okay.
Man, that's
Are
really
you,
bad.
are you in that 135 also?
Uh,
Math 135, I mean?
no, I'm not in math. I'm only in chemistry.
yes, I'm like, this is not a writing intensive math class. Like
What math are you in?
135. Like I could show you the test of where she's like, I need a written out answer. Or this isn't the right. Harbin, yeah, dude. She's like after my GPA, and it's really upsetting me.
Can I play, or you guys wanna?
Wait, I'm almost there.
I'm almost there.
I'm doing the adding that all up.
I'm honestly not trying. I'm sorry.
I'm trying.
It's whatever.
This one looks like you should try it though, because this one looks a little bit more complicated.
The same one as the last one.
No, it's not.
Method's the same.
Of course,
Wait, did you-
method's
did
the
you
same.
get,
They're algorithms.
Did you guys multiple choice answers for this or?
No, this is just from the book.
Okay. I have my answer.
Did you get -173.2?
Minus 5.
No.
So it's whatever this is.
It doesn't
Minus the first one
really
5
break
times the
down.
second, 3 times the third.
No, it's gonna be positive because the first one is gonna be
No, it's minus because this is on pentane.
negative.
Yeah.
Oh. 1H plus 5 H2s plus 3 H3s.
Yeah.
Okay, that's what I did. Negative 3, 2, 3. Just read it. 2, 4.
Yes. Work it out and then let me take a picture.
Plus
No, just kidding.
Oh, okay. I don't know what I did on the first one, but negative 173.2. Is that what you got? Okay. And this is in what units?
Kilojoules per mole reaction.
Sometimes the units throw me off. Because in the original equation, oh yeah, it's on the right.
Yeah.
Okay, I like this. this chapter.
Yeah, students usually like this one.
Peter.
Oh.
You didn't hear me. Negative 173.2 is what you, golden.
I have a candy.
You see that?
I know, it's really bad.
I like those eclipse mints.
Oh yeah. I was always into the candy apple apples.
I don't really like the full size Altoids because they're all chalky.
Now I see how this could be a fun puzzle.
You did?
Yeah.
Did he give you credit for it not being on the lab paper?
He did.
Who did? I had to email him. I was like, yo, you
All
gave me
right.
a
So
zero.
are you guys following the solution here? Nope. Questions?
Round 30?
Absolutely.
Okay.
Okay, I'll do the same.
Did you do this in the morning class too?
Yeah.
Okay.
They had time for one more problem. You guys are more talkative, which is fine. I don't know if we can try and do another problem, but I can do it fast. Oh no, it's not coming.
What?
Yep, that works.
And that was too fast.
Yep, got it.
You just wrote the answer. Now why even try?
Do you want me to erase it?
It's okay.
Where is the answer?
You put the negative h and then the 2h3.
It'll give me 2 I don't know.
Okay, so I got let's see.
Did you already? For C plus 2H2, CH4?
Yeah, I put the first one.
And you put it because CH4 is in the right-hand side of the top problem.
Oh, Michael, you can email me too. That's the other thing. If you want to talk over email, you can talk in person too. Whatever you prefer. Phone, carrier pigeon, smoke signal. Or I've been watching Game of Thrones. How about crows?
European or African swallows?
Is it unladen?
205.9.
Negative 276.3. Oh, wait. Type something. 206.3.
205.9.
0.7.
I got that twice.
Negative 92.3. Did you reverse the first one?
Uh-huh.
Did you multiply the last one by 2?
74.4 plus negative 95.7 plus 2 times negative 92.3.
And you got
205.9 twice.
negative 206.3.
74.4 plus 95.7 plus 2 times negative 92.3. Yeah, 3 times.
Your order of operations, right?
Yeah. I'm putting it straight into my calculator.
Because that 2 times negative 92.3 needs to be one thing.
What did you get? Negative 205.77.
Negative 206.3.
Let's try this one more time.
You're doing 74.4
Parentheses,
plus a negative 95.57 plus negative 92 times 2. 92.3 times 2.
Yeah. Oh, shit. 92. I did 92.5, sorry.
I did this like 3 times.
Sounds like a
What are
radio
you
station.
getting, Victoria?
205.9?
I got negative 205 or positive?
Negative 205.
Yeah, I got 205.77.
You questioned my order of operations 3 times, Peter. I'm like, no, I can do order of operations.
You guys need to get together and do your taxes. You're probably end up in jail.
My mother-in-law does my taxes.
Ugh, I did my taxes and I ended up owing the state of Hawaii $1,900. Never doing my own taxes
I can't
again.
believe you just questioned
For
my
sure.
order of operations.
I'm just teasing. I should
Yeah,
be
it's
careful.
not good.
I should be careful how I tease you guys.
What is this?
Can take it, we're big kids.
Negative 205.77
Professor.
I'm fine, but thank you.
No,
My
you're
wife
gonna
likes these. Actually, that helped. I needed a little extra energy. Now your brain runs off of sugar.
Did you bring these?
Made Halloween candy?
Got the big bag of Halloween candy from Costco. You don't have to now, we just put them in the fridge.
Last all year.
But I only came with chocolate, and I like chocolate, but I like the other ones, like those sweet tarts and stuff. Wait, take my kids' candy.
We got 2 minutes left in class.
What's the answer?
Negative
It's
205.9. Is that what you got?
I got 205.77.
Type something else. Got 206.
It's because
So you guys rounded.
Yeah, around the.
Oh yeah, yeah.
7 minus 2 times 92.3.
I'm getting negative 205.9.
What? Are my decimals not right?
So it's
They're not like look at the rate. 473.
minus 74.4.
473.
Oh, snaps.
Oh,
I'm
yes.
putting I had 95.57.
7
It's just 95.7.
plus
And it was
2 times
205.9.
minus 2 or minus 92.3.
Is it just this class that you're doing the practice problems with after? Or did you invite your earlier class too?
It's everyone's invited. Well, I didn't invite the other sections, but I mean, I didn't invite my non-students. But
Can we order pizza? Domino's delivers here. I've done it before when I was really, really poor. My brother ordered Domino's here for me.
I better ask my wife permission first.
That's totally fine.
That's her
We have
lab.
weeks and weeks and weeks. She can come too.
She's out of
Because
here.
you don't get paid for these extra problem sessions, do you? You're just doing them out of the
Can't
kindness
she
of your
clock
heart.
in overtime?
There's no overtime for teachers.
Does she,
Teachers are always
Does
on.
she only work here because she doesn't work with IFA or anything so on?
She used to work with IFA. She's full time
Is
here.
anybody else coming to the
So-
actual lab?
Okay, so then class is over in like a couple seconds. Well,
Let's just pick up and move.
questions? Okay.
Okay.
That was a lot.
That was a
The
lot.
other lady for your